The following is an introduction to the TFN FB18 cable fault tester operation process. TFN FB18 cable fault tester is a set of instruments for testing 35 kV and below power cable faults and the full length of the cable. This instrument consists of 4 parts: distance meter, path meter, high voltage unit, and a fixed point unit. FB18 distance measuring unit. The instrument consists of a distance measuring host, connecting wire, charger, sampling wire, and a sampling box. Open the protective cover of the distance measuring host, which are respectively a high-definition touch screen, data port, USB port, charging port, and a switch key. Interface introduction. Press the power button, turn on, and wait for the system to load. Click on the sampling method to select different sampling methods. There are 3 methods to choose from: low voltage pulse, flashover method, and a speed measurement. Low voltage pulse method can test the full length of the cable, low resistance short circuit fault, and broken line for distance. Flashover method can test the fault distance of the high resistance fault. Speed measurement can calibrate the pulse wave velocity used by the instrument. After the mode selection is completed, click the orange sampling button at the bottom right of the screen to start sampling. Pulse width, cable type, reading accuracy, 3 parameters. It can be adjusted appropriately according to the length of the tested cable or the distance to the fault point. Generally, the default parameters at startup can be used. The scroll and zoom keys can be used to adjust the screen waveform for flexible viewing. Save and recall can save and recall the sample waveform for comparison. Click the Help key to pop up the operation instructions. Automatic distance judgment can automatically log the cable fault distance. The positioning key can manually locate the waveform. According to the vernier Kepler fine-tuned key, accurate movement and observation can be achieved. The median and amplitude values can be used to adjust the waveform. Adjust the size, amplitude, and position for easy observation. Equipment connection. Reliably connect the sampling line to the host. Red alligator clip and a black alligator clip respectively connect the 2 measured wear cores of the cable. After the connection is completed, click the orange sampling key to sample the waveform. The first one is a transmission wave, and the second one is a reflection wave. Click automatic distance judgment to automatically judge the distance of this waveform. The device shows that the fault distance is 32 meters. The transmission wave and the reflection wave have the same polarity, indicating that this waveform is disconnection waveform or the full length of the cable. After connecting the wires, press the orange sampling key to sample the waveform. Now it is shown that the transmission wave and the reflected wave are of opposite polarity, indicating that it is a short circuit fault. Click on automatic distance judgment to judge the fault distance, and the fault distance is 32 meters. After obtaining the distance of the cable fault point, use the cable path meter to find the detailed path and find the detailed path of the cable at the measured fault distance of 32 meters. FB18 path unit. FB18 path meter with an output power of 10 watts accurately finds the path of the power cable in the energized state and the power outage state. It can also measure the cable burr depth. The working mode is divided into 3 modes: direct connection mode, coupling mode, and the induction mode. First, the direct connection mode is introduced. Use the direct connection line to connect the transmitter output port. Red connect the colored alligator clip to the cable core on the test. In the pathfinding mode, select the good phase and do not clamp the faulty phase. Connect the black alligator clip to the ground rod and insert the ground rod into the soil. The coupling method can realize the pathfinding when the cable is energized. Take out the coupling clamp, insert the 5-core interface into the transmitter output port, and connect the 4-core port to the coupling clamp. After the connection is completed, wrap the coupling clamp around the entire cable to complete the signal application. Turn on the path meter and perform automatic matching. The rotation of the circle indicates normal operation. Adjust the instrument's power through the up and down keys. Click the up key to increase the power. The output power can reach 10 watts when it is full. Click the blue button to select the frequency. This instrument supports 10 frequencies, and there is also resistance measurement and multi-frequency mode to choose from. FB18 path meter frequency selection reference. When using the direct connection method, select the frequency below 8,000 Hz. When using the coupling method, using a frequency of 33,000 Hz and 82,000 Hz. When using the induction method, you can select a frequency of 33,000 Hz, 82,000 Hz, and 133,000 Hz. FB18 path meter receiver. Click the power button to turn on the power. The left side is the mode key, and the up and down keys are the gain keys. F is the frequency key, blue is the sound adjustment key, and the right is the black light adjustment key. When the receiver is directly above the cable, the signal is the strongest and the number is largest. After deviation, the signal weakens and the number decreases. The direction can be observed through the arrow. The arrow points to the left to prompt the left. When crossing the cable, the arrow points in the opposite direction. Move according to the arrow prompt. The left and the right arrows appear alternately, indicating that it is directly above the cable at this time. The upper left corner displays the cable depth in real time. After finding the approximate path of the cable fault at a distance of 32 meters, use a light high-voltage signal generator and a fixed-point instrument to accurately locate the cable fault point. FB18 high-voltage unit. The function of the high-voltage signal generator is to apply a high-voltage fault signal to the fault face of the cable. The cable fault point can generate intermittent discharge so as to test the distance of the fault point and accurately locate the fault point. Equipment connection. Insert one end of the grounding wire into the grounding port of the high-voltage instrument and connect the alligator clip at the other end to any end of the capacitor. After connection, it is used at the grounding end of the capacitor. The combined grounding wire is applied at one end and 3 alligator clips at one end. The plug is connected to the grounding end of the capacitor and tightened. The first alligator clip is connected to the system ground. The second alligator clip is connected to the discharge rod, and the third alligator clip is connected to the one of the fault face of the cable. The other end of the capacitor is connected to the ball gap, and it is used at the high voltage end after connecting the ball gap. Connect one end of the high voltage line to the output port of the high voltage equipment and the other end to the ball gap. Take out the yellow high voltage line. Connect one end of high voltage line to the end of the ball gap and connect the alligator clip at the other end to the other cord of the faulty cable. Take out the signal sampling line. One end is 2 red and black alligator clips and the other end is a data socket. The 2 red and black alligator clips are connected to the 2 terminals of the current sampling box. Note that the colors correspond. Place the sampling box next to the capacitor ground wire, with the arrow pointing to the capacitor. After the connection is completed, turn on the machine. The screen displays the start or stop button. Turn the right switch to the start position. The instrument panel displays the real-time voltage. The preset voltage, current, and AC voltage are displayed below. Turn the green knob to the boost position to increase the voltage to 3 kV. Release the knob. The instrument automatically stops pre-boosting and the instrument panel pointer points to 3 kV. Touch the front end of the discharge rod to the high voltage end of the capacitor for discharge. The discharge rod indicator lights up and the pointer falls back, indicating that it is discharging at this time. The indicator light goes out, indicating that the discharge is over. Use the position between the discharge rods to touch the high voltage end of the capacitor, short circuit, and discharge the residual low voltage. After the wiring is completed, turn on the distance measuring hose and select the flashover method in the sampling method. Click the sampling button, collect the waveform, cancel the sampling, interpret the waveform, and get the full distance. FB18 fixed point unit. The instrument consists of the fixed point instrument host, connecting wire, earphones, sound pickup probe, and the connecting rod. The front of the host is the power button, noise reduction button, LCD screen, and volume adjustment knob. The left side is the earphone port, and the right side is the data port and the charging port. Interface introduction. After the instrument is turned on, enter the mode selection interface. This fixed point instrument has 2 modes, step voltage and acoustic magnetic fixed point. Click the knob to enter the step voltage mode. High voltage step voltage mode mainly tests a single phase grounding faults under direct buried low voltage on armored cable conditions. Click the knob again to enter the acoustic magnetic fixed point mode. This mode can display the cable for distance and the strength of the cable electromagnetic signal. When it is directly above the cable, the signal value is the largest, and this area displays the sound waveform. The sound waveform display can make subjective judgments on the cable distance and position based on the discharge sound side of the fault point of the tested cable. Click the knob to select. In the frequency band selection, select the 4 frequency bands according to the specific situation to effectively filter out noise. The electromagnetic gain setting can control the electromagnetic signal receiving ability to more clearly display the electromagnetic signal changes. The mode selection key can return to the step voltage mode, and the signal continuous switching function can perform single or continuous signal monitoring on the tested cable. The instrument has a strong noise reduction function. Press the noise reduction button and the instrument will enter the noise reduction mode, which will filter out about 70% of the environmental noise. It has a good filtering effect on the noise in the test. Device connection. Insert the headphone connector on the left side of the device. Connect the headphones and insert the right side of the device. Probe connection line. Unlock the probe and rod lock. The telescopic probe rod can be adjusted according to actual needs. After locking, connect the probe rod to the probe. Tighten clockwise and connect the other end of the data line to the pickup probe. Outdoor test. Sound waveform signal and electromagnetic signal will be received just above the fault point of the tested cable. Discharge once. Receive a signal noise. The stronger the electromagnetic signal, the closer to the fault point. The waveform is displayed periodically. The closer to the fault point, the louder the sound. In the noisy environment, the noise reduction function can be turned on, and the noise reduction indicator light flash once after receiving a discharge sound. It can effectively reduce continuous noise.
现在仪器没有开启强降噪模式，噪音可以进入耳机，虽然能听见明显的放电音，但是噪音太大，对使用者的感受进行了非常大的影响。现在打开强降噪功能，噪音明显减小，只有放电的一瞬间可以听到放电声。好，我们再关闭功能，噪音明显进入，放电之后滤波效果非常好。
Use a fixed point meter along the precise path found by the path meter in steps of 50 cm. Listen to the discharge sound of the cable fault point on the ground. Finally, a clear discharge sound can be heard directly above the cable fault point, which is considered to be the cable fault point. TFN FB18 cable fault tester introduction is completed. Thank you for choosing TFN.